So now we come to our next major topic, which is games of imperfect information. So up until now, when we've had extensive form games, it's been implicitly assumed that every time a player makes the choice, they know exactly where they are in a tree. So that is to say, they know what node they're in, and from that they can infer the entire path that was taken to reach that node from the root. So they know everything that has happened. So now we're going to do away with that assumption. So we're going to be able to talk about games which have temporal dynamic structure, but also there are aspects of the game state that players are not aware of. Okay, so the key technical idea here is a thing called an information set. And we're going to augment our game trees with a bunch of information sets, and that's going to be what defines a game of imperfect information. So an information set is a set of nodes, is a subset of the set of nodes in the game tree. So it's just like a bunch of nodes. And we're going to impose two conditions. And the idea is that when the game is in some node, then the player who is making the choice doesn't know that they're necessarily in that node, but as far as they know, they could be in any of the nodes in that information set. So they have kind of an uncertainty over whether they are here or here or here, but they know that they're in at least one of these, or exactly one of these. So the two conditions that we're going to impose on which sets of nodes are allowed to be together in an information set is that every node in the information set has to be owned by the same player, and that every node in the information set has to have the same set of actions available, that is to say, action labels of the outgoing edges of that node. So the motivation of this is that if this was not the case, then the player being able to observe those things would kind of leak information about where they are that's going beyond what the information set tells them. So so the idea is that if the player doesn't know which of these nodes they're in, they know that they own all of them, and also they can do the same actions as all of them. Okay. Now, a game of imperfect information, we're going to define to be an extensive form game together with what's called a partition of the nodes into information sets. So by this, I mean a bunch of information sets so that every node in the tree is in exactly one of them. Every node has to be in at least one information set, and you can't have a node in two different information sets. Okay. And we're going to, so the definition which we've had before now, which is a game tree without any information sets, we're going to retroactively rename it, and we're going to call it an extensive form game of perfect information. So what perfect information means is that the players always know where they are. And you can encode an extensive form game of perfect information as a general extensive form game with information sets by saying that every node belongs to its own information set. So that is to say, we have as many information sets as there are nodes, and every information set has only one node in it. So that means that when a player is in that node, they know exactly where they are because they know that they're in some node in that information set, but there is only one, so they know that they're in that node. Okay. Now here's an example which also shows you how we're going to visualize, how we're going to draw pictures of this. So we're going to take our game tree and we're going to augment it with these dotted lines. And this dotted line means that these two nodes are in an information set together. So in this tree, we have three information sets. One contains only this node, one contains only this node, and then one contains these two nodes. Now, this is an example called the market entry game, which is a basic model in economics. So the idea here is that you have an incumbent firm, so that is, say, a kind of established corporation, and then you have an entrant like a startup. And then the first move is by the entrant, and the entrant can choose to immediately give up, in which case they get a payoff of 0, and the incumbent gets a payoff of 2. Or instead of giving up, they could continue, and then the two firms kind of fight. Both firms. So if the entrant chooses to continue enter the market, then both firms are going to have to choose 2 actions, which are fight or accommodate. And here, so we're going to say that the entrant is going to move first, but then in either case, the incumbent is going to have to choose, and they don't know, when they choose, they don't know whether the entrant has gone here or here. So this is secretly a simultaneous game, and we're going to see more about why this is secretly a simultaneous game later on. And then we have some payoff setup here. Okay, so this is set up so that, for example, if both firms fight, then it's extremely bad for the entrant. If both firms accommodate, then it's extremely good for the entrant. Okay, now when we have games of imperfect information, or this is extensive form games with information sets, we need to adjust our definition of strategies, because there are strategies in general which would cheat by like making use of information that the players are not supposed to be aware of, like exactly which node they're in. So we're going to say that if we're given an extensive form game and given a strategy, which is to say a choice of action at every node, we're going to say that that strategy is allowed or valid if whenever you have an information set, the strategy does the same action at every node in the information set. So the idea is that the strategy is not actually using any information that the player doesn't know. And we can equivalently define this. We can say that a strategy is going to be an assignment of an action to every information set that's owned by that player. And by an information set owned by that player, I mean an information set whose nodes are all owned by that player. Okay, and so the secret here is I like to think of information sets as observations that a player can make about the game state. So an observation is kind of an imperfect kind of observational measurement of the game state, where you get some uncertainty about where you are. So this is the general principle that a pure strategy should be a function from observations to actions. So for every information set we're in, we choose an action. Now, the definition of a strategy profile is going to stay the same. It's going to be a choice of strategy for every player. So if I go back to this example, a strategy for player 1 is going to be what it usually is, because these nodes both have information sets of size 1. So it's going to be a choice to quit or continue and a choice to fight or accommodate. Now, if we were in a perfect information extensive form game, player 2 would have 4 strategies, namely fight, 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 accommodate, accommodate, fight, or accommodate, accommodate. But we need to restrict which of those strategies for player 2 are allowed, because we want to insist that they do the same thing in both of these states, because they don't know which one they're in. So out of those 2, we only get 2 that are valid, namely fight in both states or accommodate in both states. So player 2, the incumbent in this game, only has 2 pure strategies. Okay, now there's a slightly gnarly technicality here to do with something called imperfect recall. So we're going to say that an extensive form game has imperfect recall if there is some path from the root to a leaf which is going to hit some information set at 2 different nodes. So this is a very strange situation, because that means that the player doesn't know where they are along the path of play. So it means that the player is kind of forgetful. For example, the player can forget how many moves have taken place. So games of imperfect recall are quite strange. And as a general rule, we're going to assume that all our games have perfect recall. So we're going to kind of implicitly assume that we have an extra constraint on what information sets are allowed to look like. Namely, an information set is not allowed to kind of wrap around. You can't have an information set that contains both a node and a node that's somewhere below it, because then you have a path that goes through it twice. There are going to be some major exceptions to this. A major exception to this is Markov games, where we're going to restrict the memory of players. So we're going to come back to these in a few weeks. But as a general rule, we're going to assume that this doesn't happen.